Let's solve this JEE Advanced 2025 math problem involving two functions, f from natural numbers to integers and g from integers to natural numbers. We're given f of n equals n plus 1 over 2 if n is odd, and 4 minus n over 2 if n is even. G of n equals 3 plus 2n if n is greater than or equal to 0, and negative 2n if n is less than 0. We're asked to evaluate four statements about the compositions g.f and f.g, and about the individual functions f and g. Let's begin with f. Is f1 1? Try n equals 1. It's odd, so f of 1 is 1 plus 1 over 2 equals 1. Now try n equals 2. It's even, so f of 2 is 4 minus 2 over 2 equals 1. So f of 1 equals f of 2, but 1 does not equal 2. That means f is not 1, 1. Is f onto? Let's look at the outputs. For odd n, f of n equals n plus 1 over 2. So f of 1 equals 1, f of 3 equals 2, f of 5 equals 3, and so on. That gives us all positive integers. For even n, f of n equals 4 minus n over 2, so f of 2 equals 1, f of 4 equals 0, f of 6 equals minus 1, f of 8 equals minus 2, and so on. That gives us all integers less than or equal to 1. Together, these two branches cover all of z, so f is onto. Now for g. Is g 1, 1? Let's check. For n greater than or equal to 0, g of n equals 3 plus 2n. That's strictly increasing. For n less than 0, g of n equals negative 2n. That's also strictly increasing. And the two branches don't overlap. For example, g of 0 equals 3, g of negative 1 equals 2. So no two inputs map to the same output. So g is 1, 1. Is g onto? G maps z to n. Let's look at the outputs. For n greater than or equal to 0, g of n equals 3, 5, 7, 9, and so on. All odd numbers greater than or equal to 3. For n less than 0, g of n equals 2, 4, 6, 8, and so on. All even numbers greater than or equal to 2. So the range of g is 2, 3, 4, 5, and so on. But 1 is missing, so g is not onto. Now g.f. We already saw that f of 1 equals f of 2 equals 1. So gf of 1 equals g of 1 equals 5, and gf of 2 equals g of 1 equals 5. So two different inputs give the same output. That means g.f is not 1, 1. Is g.f onto? F maps n onto z, and g maps z to n, but g misses 1. So g.f misses 1 too. Therefore, g.f is not onto. Now f.g. Let's compute f of g of n. Case 1, n greater than or equal to 0. Then g of n equals 3 plus 2n, which is odd. So f of g of n equals g of n plus 1 over 2 equals 3 plus 2n plus 1 over 2 equals 2n plus 4 over 2 equals n plus 2. Case 2, n less than 0. Then g of n equals negative 2n, which is odd. So f of g of n equals 4 minus g of n over 2 equals 4 plus 2n over 2 equals n plus 2. So in both cases, f.g of n equals n plus 2. That's a linear function with slope 1 and y-intercept 2. It's clearly 1, 1 and onto from z to z, so f.g is bijective. Now let's evaluate the options. Option A says g.f is not 1, 1 and not onto. That's true. Option B says f.g is not 1, 1 but is onto. That's false. It is 1, 1. Option C says g is 1, 1 and onto. That's false. G is not onto. Option D says f is not 1, 1 but is onto. That's true. So the correct answers are A and D.